Yeah, welcome you all for another presentation. Today, I would like to explain about the another new subject, that is digital electronics. This is one of the another very important and core subject of electronics branch. In fact, it is a very interesting and very scoring subject in both the GATE examinations as well as UPSC's IAS examination, right? So this is one of the very, uh, I mean, uh, favor subject of any electronic student, right? Today I would like to give you brief information about digital electronics. Okay, so this digital electronics consists of two important categories actually. So this can be divided into broadly in two categories. Okay, so the first one is combinational circuits, right? The first is combinational circuits. I can write like this: combinational circuits, and the second part of it is sequential circuits, right? The second part is sequential circuits. This is the major difference of a digital electronic subject as far as GATE and UPSC IAS examination is concerned, right? Remember that the first part is combinational circuit and the second part is sequential circuit. What is the difference between these two? Or you can call it as part 1 or part 2, is it not? Okay, so what is the combinational circuit? What is a sequential circuit? Combinational circuit is nothing but, so simply remember that it needs it needs it needs no external it needs no external clock pulse. What is that? Clock pulse for their operation. Okay, for their operation, so they need not require any external clock pulses for their operation, whereas in sequential circuit they need clock pulse. That is the basic, very important difference between these two. In further subsequent presentations, I will give you more information about what is the clock pulse, why it should need, what is the purpose of that clock pulse, okay, how we apply or what happens to the circuit if we apply the clock pulse. Okay, for the time being, you remember that combinational circuit means it has or it needs no external clock pulse, whereas the sequential circuit needs external clock pulse for their operation. That is the very important, very basic difference between combinational circuit and then the sequential circuit, right? So in today's presentation, just I will focus on combinational circuit. Means that what is a circuit actually? Okay, what is a circuit? What it has actually? So okay, so in today's presentation, just we will see with respect to our GATE examination point of view, right? So in the combinational circuit, basically this describes about the logic gates basic logic gates basic logic gates it okay, it describes about basic logic gates. In fact, the digital electronics subject describes about the information or the message, whatever the information we want to send or transmit, that is in terms of the binary information actually. Okay, this describes about the information in terms of binary. Okay, in terms of the binary, what is the binary? Binary is nothing but, so it has or the information is represented in terms of either 1 0. The total information is represented in terms of ones and zeros. That is called binary, because the very beginning basic introductory topic in this digital electronics is the numbering system. Okay, numbering system. This we will see in next class, actually in the next presentation, that is number system. This is very basic topic actually. This we will see in the next subsequent presentation. In number system, basically we have at least binary number system, octal numbering system, hexadecimal number system, okay, or decimal number system. Basically there are four varieties number system is there. Means that to represent the information, we can represent the information in four different ways. That is, in binary number system, the same information can be represented in terms of binary number system. The same information can be represented in decimal number system, okay, decimals, and then the same can be represented in octal, and the same can be represented in hexadecimal. Is it not? There are four ways of representing of that particular information that describes under this numbering system or simply number system, out of which this is the first actually binary number system. Binary means that the information is represented in terms of ones and then zeros. That is called binary system. Okay, so that is very primary and predominantly important while discussing about this digital electronics, right? So the information is represented in terms of ones and zeros. Just you remember for the time being, and the remaining number systems that we will see in the subsequent, presentations, right? So in the combinational circuit, basically there are certain basic logic gates are there. Okay, they will perform certain operations on the input actually, and correspondingly they will provide the relevant output. Okay, so what are the basic logic gates? What are the basic logic gates that we will see now? What are the basic logic gates? So in this basic logic gates, okay, what are the basic logic gates actually? Basically there are certain gates are there. Out of those, the first one is called as AND gate. What is that? AND gate. This is AND gate. And the second one is OR gate. OR. Okay, OR gate. Is it not? OR gate. Or you can write anything. Okay, OR gate. And then NOT gate. What is this? NOT gate. And then there are NAND gate. NAND. NAND gate. And then NOR gate. Is it not? NOR gate. And then XOR. This is called XOR. XOR gate. And then XNOR. The next one is XNOR gate. These are the different gates normally. Okay, so AND gate, OR gate, NOT gate, NAND gate, and okay, exclusive OR gate, exclusive NOR gate. Okay, exclusive OR gate, XNOR gate. These are the various gates normally we can come across throughout this subject actually. So what are these gates basically? Just I will explain you little bit about these gates actually. If you consider the first one is, what is AND gate? What is AND operation? What is the AND gate? Okay, so the AND gate, what is this? The AND gate looks like this. It is very simple basically. The physical representation of an AND gate is denoted by, it is like a symbol of D. That's it, a symbol of D. If you put, these are the corresponding inputs and this is the output actually. So this is represented like this actually. This is a symbol of D, and if you can write, so these are called the input terminals or inputs actually. These are called inputs. This is called output. Okay, so here let us call it as something A and then B, means that at the input side, this is called input actually, these are the inputs. Okay, so this is the our output actually, you can call it as some C. Okay, this is in here, you can write and or unding, you can call it as unding operation. Okay, so the inputs are A and B and the output is C. Okay, now this is called a two input AND gate. This is called a two input AND gate because two inputs we are applying here, A, B are the inputs, and okay, we have one output as C, is it not? So there are three inputs also. If you consider the three input AND gate, you add one more line here, you can call it as some C, then you can take it as some D, nothing wrong in that, is it not? So basically we will study about two input and then three input. Most of the time we will discuss about two input only, most of the time. Okay, so this is one of the basic gate which is called AND gate. So for two input AND gate, how the output will be? There is a relation between the output in terms of the input. So the output C is equal to, it is called A into B. This is the Boolean expression. This is called Boolean expression. Boolean. Okay. This is called Boolean expression. That output expression is no C is equal to A into B. Means that what you know. So for the AND gate, the output C is nothing but it is simply the multiplication of the input A into B. Is it not? So A into B. That is what the output of the AND gate. Means that what you know. So these are the two inputs basically. So these two inputs you can give different, I mean you can apply with a different combinations. How that combinations will be given, that in terms of binaries only. Remember that as I already told just now, the inputs can be applied in terms of the binaries. So means that what, binaries is nothing but the information will be applied in terms of zeros and ones. Means that your inputs must be in terms of zeros and ones. Therefore how many inputs are there? So there are two inputs. Therefore how many combinations will come here? Means that remember that the total number of combinations can be given as the total number of combinations. Okay, the total number of combinations of input, very important point it is, the total number of combinations will be 2 power n. What is that? 2 power n is the total number of combinations and input. So here n represents, n is equal to number of inputs, where n is equal to number of inputs. Therefore how many inputs are there? A and B, two inputs only. Therefore if you substitute okay, at the place of n, it is simply nothing but 2 square. 2 square is nothing but how much? 4. Means that what? 4 combinations will come. How many? 4 combinations. What are those combinations? What are those 4 combinations? That is important. So that is nothing but what are those 4 combinations? Means that, so here the input, if you can write, there is a truth table, that is called truth table of AND gate. Truth table of AND gate. What is the truth table? It is a simply table basically. It is a simply table. It has like this inputs, it has inputs and then output. This is called output. So what are the inputs? A and B. There are two inputs are there. Output is C because two inputs only. Therefore how many combinations? There are 4 combinations. What are those? So those are 0, 0, next 0, 1, next 1, 0, 1, 1. These are the combinations actually. Means that your input A and B both can be 0. You can give your inputs as 0, 0. You can apply A as 0, B also 0. That is first combination. And for the second combination, A can be retained as 0. Now you can change B as 1. Means 0, 1 like this. And the third combination, you can change the first one, means A, as 1 and B you can change as 0. That is third combination. And the fourth and the last combination is 1 1. You can change AB as 1 1. So these are the basic possible how many combinations are there? 0 0 first combination, 0 1 second combination, 1 0 third combination, 1 1 fourth combination. There are 4 combinations are there because the inputs are 2. Say for example, if the inputs are 3, means A, B, C, let us say, then how many combinations will come? 2 power n again. So substitute at this place of n, substitute 3, therefore 2 power 3 means that how many? 2 power 3 is 8. 8 combinations will come here. Instead of 4, you will get 8 combinations. That we will see in the next presentation how it will be. Now, what is your output C? C is nothing but A into B. Now, nothing but what? A into B nothing but 0 into 0. It is 0. 0 into 1, 0. 1 into 0, 0. 1 into 1, 1. This is the output of AND gate. Is it not? So, for a 2-input AND gate, if the applied inputs A and B are 0, 0, if the both inputs are 0, the output will be 0. Okay? Means that so all remember that in a digital electronics subject point of view, the inputs 0 called as it is logic 0 or low level. The inputs are low level, low input, whereas if it is 1, it is called as high level high or high. 0 is called as low, 1 is treated as high. Therefore, so if the both of the inputs are high, then only the output will be high. So for other than this combination, if any one of the input is low, then your output will be obviously low. So any one of the input is low. Low means if A is 0, so in this combination A is 0, in the second combination A is also 0, third combination B is 0, means that for any one of the combination, if any one of the input is 0, definitely your output will be 0, because 0, it is the ANDing. Multiplication is called as AND operation, ANDing operation. Therefore, for if the inputs are high, then only the AND gate will give the high output, otherwise it gives 0 output. So this is the very simple basic information about this AND gate, and with this I will finish off this presentation and will continue the rest part in our subsequent presentations. Okay, I hope that you understood well this, and thank you for watching this.